Determine the limit as x approaches positive infinity and as x approaches negative infinity of the square root of 6x to the 6 minus 5x cubed divided by 2x cubed plus 4x. The highest power term in the numerator is the square root of 16x to the 6. In the denominator, the highest power term is 2x cubed. The square root of 16 is a 4. The 4 and the 2 can cancel down, leaving a 2 in the numerator. The square root of x to the 6th, square root is 1/2 power, 1/2 of 6 is 3. It will be x cubed, however, since the power was even and the root was even, it will be the absolute value of x cubed. A power in an absolute value can move outside of the absolute value. The absolute value of x is equal to positive or negative x, depending on whether x is positive or negative. A positive cubed is positive, a negative cubed is negative in x cubed. The x cubes can cancel, leaving 2 times a positive or negative 1, which equals to positive or negative 2. So the limit as x approaches positive infinity, x is positive, the absolute value of x will be positive, positive cubed is positive, and the limit will equal to positive 2. So the limit as x approaches negative infinity, x is negative, the absolute value of x will be negative, negative cubed is negative, and the limit will equal negative 2. Now to show that this is the case, starting with the limit as x approaches positive infinity, the square root is 16x to the 6 minus 5x cubed divided by 2x cubed plus 4x. The first thing to do is try plugging a positive infinity in for each of the x's. Only the highest power term in the numerator and denominator will matter here. In the numerator, positive infinity to the 6 is positive infinity times 16 will be positive infinity. The square root of positive infinity is positive infinity. In the denominator, positive infinity cubed is positive infinity times a 2 will still be positive infinity. The result is positive infinity over positive infinity. We have the infinity over infinity indeterminate form here. We will need to rework this. And it will be reworked by dividing both the numerator and the denominator by the highest power of x in the denominator. That will be x cubed. So we will divide the entire root in the numerator by x cubed, and each term in the denominator also by x cubed. In the numerator, the root can extend over the x cubed. By writing it as x cubed squared, because the square root of x cubed squared will be x cubed. In the denominator, the first term, the x cubes, will fully cancel, leaving a 2. In the second term, one of the x's in the denominator will cancel with the x in the numerator, leaving a 4 over x squared. In the numerator, each term can be written over x cubed squared. x cubed squared, you multiply those exponents, 3 times 2 is x to the 6th. So each term can be written over in x to the 6th. We'll leave the denominator alone. The first term in the numerator, the x to the 6th can cancel, leaving a 16. In the second term, 3 of the x's in the denominator can cancel with the 3 x's in the numerator, leaving a minus 5 over x cubed. Each term that is a constant divided by x to a positive power will go to 0 as x approaches positive infinity. Resulting in the square root of 16 minus 0 over 2 plus 0. 16 minus 0 is 16, 2 plus 0 is 2. The square root of 16 is a 4 over 2, and 4 divided by 2 will be 2. Now to work out the limit as x approaches negative infinity of the square root of 16x to the 6 minus 5x cubed divided by 2x cubed plus 4x. First thing to do is plug negative infinity in for each of the x's. Only the highest power term in the numerator and denominator matter here. In the numerator, negative infinity to the 6th power will be positive infinity times 16 will be positive infinity, and the square root of positive infinity is positive infinity. In the denominator, negative infinity cubed will be negative infinity times 2 will be negative infinity. The result is positive infinity divided by negative infinity. We have the infinity over infinity indeterminate form here. We will need to rework this. To rework this, we'll divide both the numerator and denominator by the highest power of x in the denominator, that is x cubed. However, since x is approaching negative infinity here, and one of the highest power terms is under a root, it's happening in the numerator, we'll divide, instead of by x cubed, we will divide by a negative x quantity cubed. Now a negative x quantity cubed, negative cubed is negative, and then x cubed. So we're going to divide the numerator and denominator by negative x cubed. In the numerator, that will give the square root of 16 x to the 6 minus 5x cubed all over negative x cubed. In the denominator, each term will be divided by negative x cubed. In the numerator, the square root can extend over the negative x cubed. By writing it as negative x cubed squared, because the square root of negative x cubed squared will be negative x cubed. In the denominator, first term, the x cubes will cancel, leaving 2 over negative 1, which is a negative 2. In the second term, one of the x's in the denominator can cancel with the x in the numerator, and the positive and negative will multiply to be minus, and it'll be 4 over x squared. In the numerator, each term can be put over negative x cubed squared. Well, negative squared is positive, and x cubed squared multiplying the exponents 3 times 2 will be x to the 6. So each term in the numerator can be put over positive x to the 6. The first term in the numerator, the x to the 6, will cancel, leaving a 16. In the second term, 3 of the x's from the denominator can cancel with the 3 x's in the numerator, leaving a minus 5 over x cubed. We'll leave the entire denominator alone. Each term that is a constant divided by x to a positive power will go to 0 as x approaches negative infinity. This will result in the square root of 16 minus 0 divided by minus 2 minus 0. 16 minus 0 is 16. Minus 2 minus 0 is minus 2. The square root of 16 is a 4 over minus 2. Positive over negative is negative. 4 over 2 is a 2. So it equals negative 2. And there's the results of the two different limits.